Hey guys! Welcome back to the laboratory. In this video, we are looking at corrosion. By the end of this video, you should be able to define the terms corrosion and rusting, describe different methods to prevent corrosion of metals, and explain why iron will or will not rust in different environments. So, let's go. When a metal reacts with oxygen in the air, a metal oxide is formed. We say the metal has been oxidized. Corrosion happens when the metal continues to oxidize, breaking down and becoming weaker over time. The more reactive a metal is, the more rapidly it corrodes. For example, sodium is a very reactive metal. When a new layer of sodium is exposed, the shiny surface quickly turns dull as it reacts with the oxygen in the air to form a thin layer of sodium oxide. The word equation for this reaction would look like this. Other metals, such as aluminium, are fairly reactive and would be expected to corrode quickly. However, the oxide layer formed when the metal reacts with oxygen in the air forms a protective layer, known as a tarnish, which prevents the metal from reacting any further. In contrast, highly unreactive metals such as gold do not corrode at all. This explains why gold is commonly used to make jewelry. Rusting is the term used to describe the corrosion of iron metal specifically. Rusting occurs when iron metal reacts with oxygen and water. Both oxygen and water must be present for the rusting of iron to occur. If either of the two substances are absent, the iron metal will not rust. For example, let's say we had 3 separate test tubes, each of which contained a single iron nail. In the first test tube, we have water, meaning both oxygen and of course water are present in the test tube. In the second test tube, we have boiled water covered by a layer of oil. Boiling the water removes any oxygen dissolved into it, and the layer of oil acts as a barrier to prevent oxygen from the air dissolving back into it. This means that in the second test tube, only water is present. In the final test tube, we have calcium chloride, which absorbs moisture from the air. This means that only oxygen is present in the final test tube. The results of this experiment would show that both oxygen and water are needed for rusting to occur. The only nail that rusts is the nail in test tube 1, as both water and oxygen are present. The nail in test tube 2 does not rust as oxygen is absent, and the nail in test tube 3 does not rust as there is no water present. Despite these findings, it is almost impossible to avoid the rusting process of iron, and so a number of methods are used to slow the process. The first of these methods is to paint the iron metal. The paint provides a layer that acts as a barrier, preventing oxygen and water contacting the surface of the metal, and thus preventing the iron from rusting. Oil can also be used to prevent the rusting of iron. Much like paint, coating the metal in oil produces a barrier which prevents the oxygen and water contacting the surface of the metal. Sacrificial protection is a method of rust prevention whereby the iron metal is coated in a more reactive metal, such as sodium. The more reactive metal sacrifices itself by reacting with the environment, providing a barrier to the iron metal and thus protecting it from rusting. Here's an example of a quick task you can attempt to test your understanding of the content covered in this video. Pause the video and take your time to work through each question. For an extra challenge, rewrite the statements you have concluded to be false and make them true. Press play once you're ready to check your answers. Let's talk through the answer to each of these statements. The first statement is a bit of a tricky one if you're not paying full attention. This statement is indeed false, as the term rust is exclusively used to describe the corrosion of iron metal. The correct statement should read that most metals corrode, as less reactive metals such as gold are excluded. The second statement is indeed true. Both water and oxygen are needed for iron metal to rust. This brings us nicely onto our third statement, which is false. Iron rusts when it reacts with oxygen from the air, not nitrogen. Statement 4 is true. Painting iron provides a barrier that prevents the metal from rusting. Statement 5 is also true. More reactive metals can be used in prevention methods such as sacrificial protection to prevent the rusting of iron. Statement 6 is false. Keeping a bike indoors does not exclude it from exposure to water and oxygen. Therefore, the rusting process would still occur. Statement 7 is also false. Reduction is the term used to describe the loss of oxygen. When a metal corrodes, the metal reacts with oxygen in the air and therefore gains oxygen. The correct statement should read that corrosion is an example of an oxidation reaction. And finally, statement 8 is false. Copper metal is less reactive than iron, therefore it cannot be used to prevent the rusting of iron. A more reactive metal, such as sodium or aluminium, must be used for this method of rust prevention to be successful. So, how did you do on this task? Let me know in the comment section below. Anyway, that's it for this video, guys. Thank you for joining me in the laboratory. Please leave a like on this video if you found it useful, and don't forget to subscribe to the channel so that you don't miss another one. See you soon!